Section 5-6, a definite integral. All right, before we start with actual 5-6, let's talk about something that's going to help us here in 5-6. Everything that we looked at until now, we had a curve that was above the x-axis, and we found the area between A and B, between the curve and the x-axis. What if I have a curve y is equal to f of x that's below the x-axis like this, okay? And they want me to find it, or estimate the area between 0 and 1 in this curve. So they want the area between 0 and 1 right here, okay? So what they're looking for is this area right in here. And suppose they tell us to use two rectangles. So I'm going to break this up with two rectangles. Maybe I'll use rectangles that look like this, okay? My first rectangle that looks like that. And my second rectangle maybe is going to look like this, okay? Alright, so let's see. We had 1 on the x-axis here, so that would be 1/2, right? So if I want to calculate the area here, or if I want to estimate the area by using those two rectangles, I'm going to say area is width times height. So we would say 1/2 is the width of this rectangle, right? What is the height of it from here to here? So that's my function f be evaluated at 1/2. All right, 1/2 a little better. It's my function f evaluated at 1/2 plus the area of the other rectangle, which has a width of 1/2, times f evaluated at what? 1. All right, so that gives me 1/2 times, what's f evaluated at 1/2? My function f right here at 1/2 is what, a -2? So f at 1/2 is -2 plus 1/2 times f at 1. What is my value of my function f at 1? That's -1.5, right? Or I could say -3/2. So what happens whenever you calculate this area is you get -1 minus what, 3/4? So what kind of value does that give you? That gives you a negative value, right? So whenever we're talking about area, the way we estimated the area using those rectangles and those function values, we can actually have negative area. And in fact, what we're going to have is, if we have the area between the x-axis and the curve is below the x-axis, like this picture, it's going to be negative area. And if the area between the curve and the x-axis is up here, or above the x-axis, it's going to be positive area, okay? That's where net signed area comes in, okay? What does this read? If a function f is continuous on the interval AB, then f is integrable on AB, and the net signed area A between the graph of f and the interval AB is given by the integral from A to B of f of x dx. And that's what we call a definite integral whenever we have these numbers here, okay? Or what we call our limits of integration. Okay, so what are they saying the net signed area is? Net signed area is given by this right here, okay? In other words, big picture wise. Let's suppose you have a function that does this. Okay? And here is A right here, and here is B right here, okay? The net signed area will be the area up here, which is positive, plus the area down here, which is negative, okay? And the way we write the net signed area is with these symbols, okay? All right, so let's take a look at our first example here. Our first example reads, sketch the region whose area is represented by the definite integral and evaluate the integral using an appropriate formula from geometry. All right, so they want me to evaluate this integral. The integral from 3 to 5 of 4 dx. That's part A, okay? Now, how do they want me to do this? They want me to use an appropriate formula from geometry. So let's draw a picture of what this thing looks like. So what is my function f of x? F of x is equal to 4. Okay, the function will be f of x is equal to what's inside the integral sign. So I could draw a picture of that. F of x is equal to 4. What does that look like? That looks like this, a horizontal line, right? F of x is equal to 4. Now what are they saying here? They're saying because it's an integral, they want the area under the curve, but in particular here, they want it between 3 and 5. So go here to about 3, and then go here to about 5. And what they're looking for is they're looking for this area right here between the curve and the x-axis and between 3 and 5, okay? So they say use a formula from geometry. So I'm going to say this area from 3 to 5 of 4 dx is given by a rectangle, right? So how do you find the area of a rectangle? Length times width, right? Or we could say this width times the height. Now, how wide is this from 5 to 3? Well, that's 2 units, right? Times, what is the height right here? How tall is this? This goes from 0 to what? 4 right there. So that's 4 units tall. So 2 times 4 will be 8. So what are we saying? We're saying, yes, this integral from 3 to 5 of 4 is 8, right? Or we could say the net signed area between 3 and 5 and the curve in the x-axis is 8. The net signed area is 8. Let's look at part B. Part B wants us to do something similar here. Actually, it's the same directions. What do they say though? They say that we have the definite integral. What makes it a definite integral again? Is that we have numbers here which are called limits of integration. Alright, so the integral from negative 2 to 4, 3 halves x plus 6, and put your dx on the end, okay? So they want me to draw a picture of this and then find the area under the curve using a formula. So let's draw a picture of what this looks like, okay? Here's your x-axis, here's your y-axis. 3 halves plus 6 is a curve with a positive slope of 3 halves, right? And it goes through the y-axis at 6. All right, now, where do I want to look for the area between negative 2 and 4? So maybe here I have negative 2, maybe here I have 4, okay? So I know my line's going to do something like this, right? That's f of x is equal to 3 halves x plus 6. Now I want this area from negative 2 to 4 right here. So I want this area under my curve. Now, what is the height right here? Because this figure makes a what? Trapezoid again? So what is the length of this base right here, my trapezoid? Well, what is this point right here on your curve? That's a point negative 2 comma what? Well, sub in negative 2. Or here, doesn't matter. Negative 2, I'll get what? Negative 3 plus 6, and I'll get 3. So then, wouldn't that make the base length right here 3? All right, what is my base length right here? Well, I know at this point right here, my x value is 4. What is my f of x value? What if I plug in 4 here? I'll get what, 6 plus 6 or what? 12? So what's the length from here to here? That would be what? 12, right? Now, what is this height of my trapezoid there? 4 minus negative 2, or 6, right? So if I want to evaluate this integral from negative 2 to 4, 3 halves x plus 6, what am I really doing in this example? Because they tell me to use a formula from geometry, I'm going to say this is equal to 1/2 times base 1 plus base 2 times height as my formula for the area of a trapezoid. So that's 1/2 times base 1, which I could say is 3, plus base 2, which I could say is 12, times the height of what? 6. So what does that give me? 1/2 times 15 times 6, and what does that give me? 45. So the area here is 45. C. Let's look at C. C is in cat. All right, for part C, we're going to have the integral from 0 to 2 of the square root of 4 minus x squared dx, okay? They want me to draw a picture and use a formula from geometry to calculate this. All right, let's see. What is this shape? F of x is equal to 4 minus x squared. Well, that's part of a circle, isn't it? Remember, a circle centered at the origin, I should say, is x squared plus y squared is equal to r squared, the formula for it. So basically what I have there is x squared plus y squared is equal to 2 squared. So x squared plus y squared is equal to 4. And what if I solve for y? I'll get y squared is equal to 4 minus x squared. Then if I take the square root of both sides, y is equal to plus or minus the square root of 4 minus x squared. That's basically what I have right here, right? Square root of 4 minus x squared. But I do not have the minus case. The only case I have is 4 minus x squared under that radical that's positive. So what shape does that make then? That makes a semicircle with a radius of 2. Semicircle with a radius of 2. 1, 2. 1, 2. 1, 2. And the top half of it is that positive square root that we're looking at. All right, so what are we doing here? We're trying to find the area. Well, not that area. We're trying to find the area under this curve between what? 0 and 2. Between an x value of 0 and 2. So I'm looking for this area right here. All right, so the integral from 0 to 2 of the square root of 4 minus x squared dx, if we use a formula from geometry, what do we have there? A portion of a circle. What's the formula for the area of a circle? Area is equal to pi r squared, right? Well, in this case, my area will be pi r squared, but I'm only looking at how much of a circle if I complete the whole circle. What's shaded in? Only what? 1/4 of a circle, right? So my area is going to be 1/4 pi r squared. So if I fill in 1/4 pi, what is r in this case? What's my radius? 2 squared. So what does that give me? Pi. My area under my curve there is pi.